Yeah, sure. Great. Okay, so uh, yeah, I appreciate the opportunity to share my ideas through AIVC, the Annex 87 webinar. So my name is Joon-Ho Choi. I'm an associate professor of building science and associate dean of research and creative work. So we recently launched a new research center on campus. So that is a center for wellness in the built environment. So I'm also currently working as a director for the center. So I think it will be a good opportunity to share the ideas and also vision through NX87. So today, I'd like to review the current state of the art and in wearable heating and cooling technologies and share my relevant recent work with you. And then I also suggested some ideas for future work. Okay, so historically, our building environmental control has been developed as illustrated in the diagram. So we started with a single zone control, and the environmental zone has been divided more precisely by orientation and then by space usage. So which is for the multi-zonal control, and then the people started reducing on the environmental volume to control that provide very close to the user. So recently, the microcontrol, such as a cooling chair, so as introduced by Dr. Hoffman, has been emerged. So by reducing the physical distance between the control space target and user, the energy efficiency is much more enhanced while promoting the user's environmental comfort. So, well, what will be the next control mode in the HVAC domain? The answer could be the wearable cooling and heating system. So some people may say that we already have such a wearable cooling and heating stuff. So as you see, uh, you're saying may be correct. So we have a Ruber water pack and hot patch and cool seat and a partial electric blanket, etc. So there is no control solution or portability. So unfortunately, in those items. So these materials have a clear role for, however, these materials have a clear role for thermal comfort, even though they are very limited option to operate the environmental function for the users. So wearable technologies or wearable some material that must be very convenient to meet the user's thermal needs. So however, how design a wearable cooling and heating should be based on the critical finding of the human body and its thermal mechanism. So even though we frequently talk about the thermal sensation and comfort, we may easily overlook thermal sensitivity by body area and local body thermal sensation versus whole body thermal sensation. So as illustrated, introduced by Dr. Hui Zhang, so in neuroscience, many body spots have been investigated per body segment and especially for thermal and pain sensitivity. So a recent study led by the Hui Zhang here developed a thermal sensitivity and thermal sensation map of the human body as illustrated in this figure. So this study well explain how variously the thermal sensitivity and sensations are distributed over the human body. So this study quantified and the sensitivity for cooling and heating per local body and ranked by their index estimated. So in these two charts, so hand dorsum has been founded as the most sensitive body segment for cooling, and the butt is the first ranked for heating. Also, the neck dorsal, which is backside, was ranked 11th for cooling and for third for heating. So I just see, even though neck is ranked at the 11th for cooling, but the index variation over here is not much significantly large. So the neck may be the most practical area to for conditioning with its physical shape to wear something in a convenient way. So due to the reason the neck seems the most popular area for conditioning in the wearable domain. So let me turn up. Yes, so let me share some current technologies and the product available in the market or academia. The first one is a wearable thermal device developed by Sony. So it can provide cooling and heating to the neck, and it is operated using batteries, and it means that the recharging power is required. So the control is based on the manual switch through the smartphone app with a programmable function. So this operable temperature range is between the 22.4 and 41 degrees Celsius, depending on the conditioning mode. And this is another wearable cooling and heating device on the neck. So it comes with a manual control switch, so it can be worn inside or outside of clothing. So the device consists of a heat pump with a heat exchanger for cooling and provide the thermoelectric coil for heating. So this is also the wearable device, but not on the side of the neck instead of a back side. So it provides cooling and heating, and it is rechargeable through USB, and the technical feature is very similar to the previous pocket-sized device. And as such, multiple devices are available for conditioning on the neck of a user. So even though there are many other body parts or areas that are much more sensitive for cooling and heating, the back of a human body has been also frequently selected for conditioning target. So back is ranked at the fourth for cooling and the seventh for heating. Yeah, according to the Dr. Hui Zhang's study. So the ukulele is basically the wearable and portable fan on the back. And this seems to be convenient for sports athlete or special professional worker who may be easily exposed to the hot temperature. And this is another fan operating cloth. So it is for cooling only by increased airstream inside the jacket for evaporation cooling effect. And there is a battery operated heating jacket that's available to heat up the skin surface of the back and also chest area. So such a fabric is quite fragile, actually, those heating coils are, the inside of the clothing. They're quite fragile, especially during the laundry process. But this product seems to be figured out, such as physical durability limitations. So like this, the current wearable technologies are available for the neck and the back or torso. So even though many other body areas have been proved as more critical sensitive area. So most of them, unfortunately, are battery operated and recharging process is required in reality before the use. So that might be one of the critical limitations in the wearable technologies. So on the other hand, there is an effort to overcome our power issue actually. So even though this product is not completed for commercializations, the thermoelectric device basically use the body heat to collect the body temperature, the heat energy, and generate power. So we call this thermoelectric generator. So it does not have any specific cooling or heating function, but considering this device can harvest heat from the body, it potentially contribute to cooling in a certain way, I believe. So the thermoelectric, the generator, so can be platformed in the future to accommodate many wearable devices that can eliminate a separate power recharge effort. So this is designed to wear on wrist, so just like a regular the smartwatch. So as discussed, we currently have a wearable product and technology for cooling and heating available. So beyond the function of conditioning, we start generating power using the body heat to support any wearable devices, including cooling and heating machines. So in that case, what is the missing the current technical frame? So I think an automatic control is completely missing in the current technology and then in this wearable area, such as a model-based or AI-based, AI-driven control or feedback or feed-forward control, etc. So there are many other some computational algorithms available that potentially integrated with our some automatic control function. So most of current technologies adopted a phone-based application control or manual switch control with no intelligence. So the smartphone app-based control might be easy and convenient, but as you see, according to the recent studies from the Berkeley, people may not use as frequently as the beginning of their usage start because people want to be less distracted. So for an automatic control modeling based automatic comfort modeling based control, so there are many ways to provide input data to decide an operation mode. So I believe the biosignal is one of a critical input to develop a thermal comfort model as a function of a multi-data analytics method and machine learning or AI algorithm. So this is my recent study sponsored by US National Science Foundation. So we investigated which body segment generate the most meaningful skin temperature data set that can be used to estimate the user's thermal sensation and comfort. So we select 10 body points, such as forehead, neck, and chest, and also the upper, the thigh, and the limbs, and the wrist. So as you see, those are some vertical, the 1, 2, 3 over here, subject ID indicate the human subject. And even though those people are shared the same temperature in the same room, their skin temperature on their arm is completely different depending on people. So it's not surprising at all because that individually we have completely different physiological characteristics such as weight and gender and body mass index, etc. And this is the skin temperature variation per thermal sensation from individual people. So this is a sample from one of some human subject. So minus means that like a chilly condition, and plus means that the warm condition. So I just see that the temperature is going up, showing some trend to going up per body area, but their temperature ranges are completely different. So per body's location, sensing location. So forehead, arm, wrist, back, and front. So we adopted machine learning, which is specifically artificial neural network, to estimate how much accurately we can estimate thermal sensation per individual level. So when you select only one body area, so waist temperature, skin temperature, and then wrist and forehead, and some wrist, back, and front, neck, and waist, arm, waist, wrist, front combination. So depending on those some data attribute combination, the accuracy, prediction accuracy is completely different. But when we combine the more body segment data, we found that the higher accuracy rate can be achievable. But the issue is that, for example, line number 13, waist, arm, wrist, front and back, and forehead, neck. Okay, we need to collect 6 body area. We need to collect the skin temperature from the 6 body area to accomplish more than 95% accuracy. But the issue is that nobody wants to wear such some complicated wear sensors over the body. So we started using the gradient, which is a kind of change pattern. So in addition to skin temperature, and then based on the wrist front and back combination, we are able to accomplish the highest accuracy, which is almost 95%, which is quite good. So we did the validation test in an actual office building, and then we were able to accomplish 95% accuracy. So the lesson that we got here is that the human data-driven thermal sensation model can be established by using the advanced computational algorithm. And then also, there are human body itself generate a lot of significant information. And also, we need to consider a lot of some diversity in terms of physiological characteristics and such as gender, age, and ethnic origin. So it means that we need to consider a lot, multiple the human physiological information to generate a thermal comfort or estimation model, sensation model. So it should be in an individual level rather than general model level. And also, conventional and general comfort model is still effective, but there are some limitation in prediction accuracy and some individual level for an individual level. And big data. So actually, when you start collecting data using the wearable devices for sensing purpose, it generates a lot of data, a lot of noise, and a lot of the frequent data set that should be captured in a per different environmental condition. So therefore, the big data or some machine learning or AI, such a advanced computational algorithm should be well integrated with our domain so that we can provide more accurate thermal sensation and prediction model. So what should be done in the future research? So as discussed, an individual comfort model-based automatic control is a big missing in this research domain. So in addition, there are multiple agents that we should consider the future work. So for example, we need to develop the robust sensing-based thermal sensation or comfort model for an individual level with considering individual physiological characteristics. Therefore, we may need to identify feature-specific information we should integrate for accurate prediction modeling. And second one is establish a thermal sensation comfort modeling design guideline as a function of a critical sensing point on the human body. So, so it means that we may need to establish a standard sensing guideline for the future, because that there are many current studies that investigate some the human physiological information driven thermal sensation comfort model, but their input parameters and the input location is completely different depending on studies. And third one is integrate modeling result with the existing wearable system for sensing and control. So that is something that we need to balance between the software and hardware platform. And my study, for example, that I showed that that was considered only office setting for a sedentary activity as an office worker. So considering numerous environmental condition and then the buildings, typologies, and the physiological condition, there are countless combinations of those parameters that we should investigate. And last but not least, the thermoelectric generation is a cooling or heating resource. So while contributing to the power usage for wearable devices is a very novel technical platform. So wearable device or technology may suggest a way to accomplish a net zero energy performance by using this novel platform. So I think that's all for everybody. So I need to appreciate all the members' effort in our center, and then Saba Imani and other student member, and also as I mentioned, some part of the presentation based on the sponsored work by the U.S. National Science Foundation. So as mentioned by the Dr. Olson, so I'm in charge of subtask C and control operation and system integration. So yeah, so please contact me if you're interested in working together. Yeah, thank you very much.